So let's move on to the next question, guys. In this question, we are given that how many odd 3-digit integers greater than 800 are there such that their digits are different, right? So we are given a few things, that the number should be greater than 800, right? It should be a 3-digit integer, which means greater than 800 and less than 999, right? And we are also given that all the digits should be different, right? Perfect. So tell me one thing. Basically, the entire uh, domain becomes how much? 800, between 800 to 1000, right? The entire domain becomes greater than 800 and less than 1000, right? Okay, so tell me one thing. Let's divide it into two parts. One is 800 to 900, right? And one is 900 to 1000. I hope this makes pretty good sense, right? Okay, so now tell me one thing. We have 3-digit number over here and we have 3-digit number over here, right? Okay, so now tell me that how many possible options do we have for the first digit? How many possible options do we have for the first digit, right? So for the first digit, we basically have one option, which is 8, right? Because we are taking 800 to 900, right? So 801, 802, 803 up till 899. So in all these cases, the first digit is same, which is 8, right? So we only have one option. I hope this makes sense, right? Okay. Now tell me one thing, how many options do we have for the last digit? Because we know that we want odd integers, right? That means for the last digit, we can have 1 as an option, we can have 3 as an option, we can have 5 as an option, we can have 7 as an option, and we can have 9 as an option. I hope this makes pretty good sense, because we want to end the integer in an odd number, so we have these possible options. So 1, 2, 3, 4, 5. So we basically have 5 options with us for the last digit. I hope this is pretty clear, right? Okay. Now tell me, for the middle digit, for this one, how many options do we have? So we know that all the digits should be different, right? So obviously we will have one digit over here, we will have one digit over here, right? And in total we have how many digits? 10. Starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a total of 10 digits in the number system. One digit is over here, one digit is over here, right? So how many digits are left with us? We are left with 8 unique digits. So over here we have 8 possible options. I hope this makes complete sense, right? So how many total options do we have? We have 1 into 8 into 5, which means we have 40 total numbers between 800 and 900 which are odd, right? And all the digits are different. I hope this makes sense. Now let's come to this. Tell me one thing, for the first digit, how many options do we have? Only one, right? Because only 9. Because 901, 902, 903 up till 999. So the first digit is always 9. So we have only one option, right? Now tell me one thing, for the last digit, how many options do we have? Because we want to end the number in an odd number, so it needs to be odd. So what options do we have? 1, 3, 5, 7, and 9. So these are the different possible options, right? But we know that all the digits should be different, right? And what is the first digit? The first digit is 9. So therefore we cannot have 9 as the last digit, right? We cannot have 9 as the last digit because 9 is the first digit. So practically, how many options do we have left? 1, 2, 3, 4. So we have 4 options left with us. I hope this makes complete sense, right? Okay. Now for the middle digit, how many options do we have? 8, right? Same. Why? Because there are total of 10 digits. One digit has been used here. 1 digit has been used here. So we are left with 8 unique digits. So how many total options are there? The total options becomes 1 into 8 into 4, which is 32. Right? I hope this makes sense. Now let's talk about the answer. So between 800 and 900, we have 40 numbers. Between 900 and 1000, we have 32 numbers. So total, we have 40 plus 32, which are 72 numbers. So there are total of 72 numbers which are odd, 3 digit, greater than 800, and all the digits are different. So the final answer is 72. I hope this should be absolutely clear.